In this video, we're going to build the sine curve from the unit circle. You need some supplies, some string, some noodles. I like using linguini because they're flat and they're pretty sturdy. A ruler, a compass, a protractor, a Sharpie, some glue, and a big sheet of paper. You can probably use like 4 sheets of just regular paper taped end to end. We used to use book covers when we used to have books. This is a piece of butcher paper that I brought home. And you want to fold it hamburger and hot dog and crease it so that you have an X and a Y axis. Use your Sharpie and the ruler to trace it so you've got it on your paper. Next, we're going to use the compass. I have a safety compass. I center it at the origin, and I'm using a radius of 4 inches. Put your Sharpie in the little hole and then trace it all the way around. I'm going to use my protractor next and mark off your special angles all the way around the unit circle. So 30, 45 would line up right here, 60, of course 90 is marked. Let's see, we'd have 120 over here that you'd want to mark, and so forth, all the way around the unit circle. Top and bottom, and I just make my little dashes. Next, we're going to use the ruler and connect those dashes so I can trace all my angles all the way around the unit circle. Then go ahead and add your radian measures at each of these angles, like I've done in this picture. My next step is to lay the string on the circumference of the circle. It really helps to have 2 people to hold the string. You can see I use a little piece of tape to hold it down right over here, but I'm going to put this knot on my string at 0, and then I'm going to mark each of the radian angles with my Sharpie. So this first mark on my string represents pi over 6, pi over 4, pi over 3, all the way around, and try to lay it nice. Try to hit the circumference of your circle. That's really what you want to do. Ideally, you want to have your string go all the way around to 2 pi. My string ended up a little short and I didn't bring any more home with me, so I'm stuck with just this. But I know that this end of the string hits right about 11 pi over 6. All right, we're going to take that string and we're going to lay it on the x-axis. This knot, which was at 0 radians, is now going to be at the origin. So this first mark on my string represents pi over 6, that radian measure. The second mark is pi over 4, pi over 3, pi over 2, and so forth. And I want you to go ahead and mark on this positive x-axis all of those angle measures. And then, and that's what we've got here. I just used a pen to mark them on the x-axis. And then flip it over onto the negative x-axis. And so I don't know if you can see, but we've got negative pi over 6 here, negative pi over 4, negative pi over 3, negative pi over 2, and so forth, all of your negative angles. You're just counting in the clockwise direction. This is where the linguini comes in next. You're going to take a piece of linguini, and since we're graphing the sine curve, remember sine represents the y values. And so you're going to lay that linguini one end on the positive x-axis, and it goes through that angle. See where I've marked it right here? That's where I want to break that linguini at a vertical height of pi over 6. After I break that one, I'm going to break a piece of linguini, the vertical height of pi over 4, pi over 3, all of my angles. So now I have these 7 pieces of linguini, which represent the y, the vertical height, sine around the unit circle, or at least the top half. Okay, so next, because I'm going below the x-axis, I'm going to have linguini pieces that are all below the x-axis. Now, these aren't glued down or anything, they're just loose, but they represent the value of the y value all the way around the unit circle. Okay, so now that first piece of linguini that was a height of pi over 6, you're going to line it up with the mark on the x-axis that represented pi over 6. That piece goes here. Your next piece is going to go right here at pi over 4, and then pi over 3 where I've marked it, and then pi over 2, and so forth. I've got the whole top half of my unit circle laid out with linguini. All right, so remember at pi, we didn't have a vertical height, and neither with 0. I didn't mention that earlier, but the reason we didn't break off a piece of 0 is because you have no vertical height. No vertical height at pi over 6. So at pi over 6, I'm not going to have a piece of linguini. Now, the next angle, 7 pi over 6, is below the x-axis. So that piece of linguini is going to come down here. And then remember all those other pieces that were below the x-axis? This represents one cycle of our sine curve from 0 to 2 pi. Remember at 2 pi, which is the same angle as 0, has no vertical height. All right, so I used a marker and I very poorly traced the sine curve around here just so I could see it. I didn't want to glue down these linguine noodles now because I only brought home 3 noodles, but if I was at school and I had more noodles, I would go ahead and glue those down. I didn't glue them down because I also wanted to show you the negative x-axis. So I took all of those linguine noodles that were on the positive x-axis and I moved them to the left. Okay, so now think about it. If we're at 0 here and we're going negative pi over 6, that's going to be this value, this height below the x-axis at negative pi over 6. And then negative pi over 4 would be this guy. Negative pi over 3 would represent this piece. Negative pi over 2, and so forth. And so our curve here is going to be rotated around the origin from the opposite side across the y-axis. All right, so I traced it, and here it is. And again, when we were at school, we would just glue down the linguine noodles, but because I'm short on noodles, I just went ahead and traced it. Here is one positive cycle, and here is another cycle of sine. And that is the graph of our sine function.